In this assignment, you're going to see that an equation was solved using algebra tiles. And your goal is going to be to write out the algebraic steps to exemplify what happened as this was solved out using algebra tiles. And then as you write out the algebraic steps, you're also going to provide reasoning. And you'll see at the very top, I wrote down a list of the reasons you can use for this column. And then I'm going to show you now in this video the algebraic steps to write for each of these examples. So you can see here in the first step, we're going to write out what the equation is. So we got 4x's plus 8 ones, 2 negative x's, so negative 2x, and then plus 14 ones. So this is what you would write here. We have the equation 4x plus 8 equals negative 2x plus 14. And then the reasons, you look up here for the list of reasons to use. And this would be the given because that was the equation they gave to us. Now, in the next step, what you want to do is look at what changes. And you'll see here that we ended up with the same exact information as before, except that now we have this is new and this is new. So clearly we can see they added 2 x's to both sides. So when you list out your algebraic steps, you're going to see we still have 4 x's and 8 ones, just like in the previous step. We still have negative 2x and 14 ones, just like in the previous step. So I wrote that down again. And now I'm just going to put plus 2x on the left side and plus 2x on the right side. And I'm going to put it with the like terms. So this would be 2x here, and I added 2x here as well. And you'll see that I'm doing a little bit different in this example where I put it underneath. I added 2x here, and I added 2x here. And this is what I recommend is showing your work this way because you can line it up with the like terms easily. And you can clearly see, since I added 2x to both sides, this is the addition property of equality. Because remember, anytime you use the properties of equality, you want to show what happened on both sides. So clearly I can see that they added 2 x's to both sides here. And clearly in this example, algebraically, I can see they added 2 x's to both sides as well. Now in the next step, you can see here that we end up just combining the like terms. So here they combining these together and that forms a 0 pair. And over here, nothing cancels out. So we're just left with 6 x's, 8 ones, and 14 ones on the right. So 6x plus 8 equals 14. So notice they just combined these together to get 6x. Combine these 0 pairs, they cancel each other out, and we're left with just the 14 ones. And this is called simplifying when we do that. Now, in the next step, you can see here that we still have 6 x's and 8 ones here, and we still have 14 ones. What's new or different is that they took away 8 on both sides. So notice that I copied the previous equation because we still have this on both sides, but now we're taking away 8 on both sides. So since I'm taking away 8 on both sides, this is called subtraction property of equality. So I just want to point out that I like writing out underneath the equation what we did to both sides because it clearly shows we're taking away 8 to both sides. And anytime you're using a property of equality, that's what you should be showing is what happened on both sides, and it should be identical. So it stands out much more when you do it this way. And here's what I mean when I'm talking about where previously, if you can write it on the same line. So if you prefer doing it that way, that's fine. You put minus 8 and minus 8 rather than putting it underneath. So either one is acceptable. But I'm just saying that I like this way because it clearly shows we're taking away 8. It just stands out much more than the way it stands out here. It's not as obvious. And now we can see here that they combine these 8 ones negatives with the 8 positives, and that becomes 0 pairs. And when you combine these together, you get all those as 0 pairs as well. So we're left with 6x and 6 ones. So I'll write down here 6x equals 6. So notice here algebraically, when you combine opposites, they're gone. And when you combine these, you just subtract it out and you're left with 6. And don't forget to write your reason. So the reason for this part is that we're simplifying. So again, when you combine your like terms, it's simplifying. And now we can see here that these 6 x's, they were split up into 6 groups here. And these 6 ones were also split up into 6 different groups. And when you do that, when you split up into equal groups on both sides, this is called division property of equality. And algebraically, the way you show the work is, we took the 6 x's, we divided it into 6 groups, and we took the 6 ones and we divided it into 6 groups. Notice we're not dividing by x on both sides because, again, we're creating 6 groups. So it has nothing to do with the x. So you don't want to put an x there. It should just be divided by 6 on both sides. So 6x equal to 6, divide both sides by 6. That's your division property of equality. And by creating 6 groups on both sides, you can clearly see that each of these x's matches up with one of the ones. So x is equal to 1 is our solution. And algebraically, notice when you do 6 divided by 6, that's just 1x. And 6 divided by 6 is just 1. So we don't need the pictures to simplify it when we have it algebraically. We don't have to draw the groups out. We just know this will let us know how much is in each group when we simplify this out. All right, here we got problem number 2. So first thing you're going to do is write out your equation. This is 2x plus 4. and then equals negative 3x, because we have 3x's that are negative, negative 3x and minus 6. So this is your equation for the first step. And the reason would be it was given to us. All right, now looking at the next step, you can see here, we still have our negative 3x minus 6 here, and we still have 2x plus 4 here. What's different is that we have 3x's on both sides now. So we added 3x's on both sides. So the way we show that work here, algebraically, copy the original, because we still have 2x plus 4 and negative 3x minus 6, as I pointed out here. Same thing is still there, just like in the previous step, except now we're adding 3x to both sides. So I put plus 3x here, plus 3x here, and when I add the same thing to both sides, this is called the addition property of equality. After you use your addition property of equality, next step is just simplifying. So when you combine these, we get 3 zero pairs. We're left with just 6 negatives here. There are no zero pairs here, so we just end up with 5 x's. So when we add these x's, you get 5 x's. When you combine these opposites, they cancel each other out, and we're left with just negative 6 here. So this is my next part after simplifying. So simplify is your reason for this part. Now looking at the next step, you can see here, we're trying to isolate the x's, so that we got to get rid of these 4 ones. So they put 4 negatives here and 4 negatives here on this side. So that's what changes. This is what's new in the next step. So that means I'm taking away 4 on both sides. So algebraically, you're going to copy the original, right? We still got 5 x's, 4 ones. We still got 6 negatives. So that's what I wrote here. But now we're just going to be taking away 4 on both sides. And by doing that, this is called subtraction property of equality. We're taking away the same thing to both sides. And then next, you can see here, they combine their zero pairs here. So that all cancels out. And then here, there are no zero pairs. So we just end up with 10 negatives. So now, by simplifying, we're left with 5x equals negative 10. And you can see that's what I wrote here algebraically. 5x equals negative 10. So again, notice that when you do 6 negatives and 4 negatives, when you combine that, nothing cancels. When you combine 4 positives and 4 negatives, they cancel each other out, and that's why we're left with 5x. This is called simplifying. Next step, you can see here, they split this up into 5 equal groups. Took this, split it up into 5 equal groups. When you do that, this is called the division property of equality. And the way we show it algebraically is you take your 5x's, you're dividing it by 5, and then you take your 10 negatives, and you're dividing it by 5. So this is how you model it or show it algebraically, that we're dividing it into 5 equal groups on both sides. And by doing this, you can see clearly that each x matches up with 2 negatives. So x equals negative 2, right? You can see here algebraically, 5 divided by 5, we're left with 1x. And then 10 divided by 5 is 2, and we're dividing negative 10. So we get negative 2 as our answer. And this right here is our solution. And then here is our third example, the last example. We can see here that we have 3 x's, or 3x over 5s, 3 of those, and 3 1s. And here we have 2x over 5s and a negative 1. So the way you write 3 of these is you're going to put 3x over 5. And on the other side, we have 2 of the x over 5, so we put 2x over 5. So 3x over 5 plus 3, right? 3x over 5 plus 3 equals 2x over 5 minus 1. So 2x over 5 minus 1. That's our equation, and that was given to us, so that's our reason. All right, looking at this step here, you can see what changes from the previous step to the next step. We can see here that we still have 3x over 5 and 3 pluses here, 3 1s, and we still got 2x over 5s and a negative 1. What's new is this part right here. They took away 2x over 5 on both sides. So algebraically, I took my original equation and we took away 2x over 5 on both sides. So notice that I'm putting the steps underneath, because by putting underneath, it makes it obvious that this is the subtraction property of equality, because I'm taking away the same thing to both sides. And then next, you can see here we combine these and we get the 2 zero pairs. Combine these, we get 2 zero pairs, and we're left with x over 5 plus 3 and equals negative 1. So again, by taking these, subtracting it, we're left with 1x over 5. I'm still left with 3 positives. Subtract these are opposites, so they cancel each other out, and we're just left with negative 1. And this is called simplifying. Now looking at from this step to this step, what changes, you can see here that we now have 3 negatives on both sides. So everything else is the same, except we have negative 3 on this side and negative 3 on that side. So that means that on the left side, we took away 3. On the right side, we took away 3. And by doing that, that's called subtraction property of equality. So notice we took away 3 to both sides. As you can see from here to here, took away 3, took away 3. And then in the next step, you can see here, we combine these 0 pairs. So we're left with only x over 5. There are no 0 pairs here, so altogether we have 4 negatives. So you can see again, combine these are 0 pairs, they're gone, we're left with x over 5. There are no 0 pairs on this side, so when you combine these, you'll end up with 4 negatives. This is called simplifying. Now on this next step, this is the one that most people make the most mistakes with. Notice that here we have x over 5, and now we end up with 5 copies of the x over 5. And over here we have 4 negatives, and now we have 1, 2, 3, 4, 5 copies of that. So whenever you increase the copies of something, you're basically multiplying, right? We have 1 copy, now we have 5. We have 1 copy, now we have 5. So essentially we're multiplying both sides by 5 because we're making 5 copies on both sides. That's called multiplication property of equality. And the way you show the work for that algebraically is we know we have 5 copies of that one, so I'll put 5 times that amount. And we have 5 copies of the negative 4, so I'll put 5 times the negative 4. So again, I just want to point out that anytime you show a property of equality, you want to show what you did to both sides, this identical. Because the property of equality means you're doing the exact same thing to both sides. So since I did times 5 here, I'm doing times 5 here. The mistake that I saw most common is that they just put down 5 times that, which is negative 20. But remember, we're not showing, we're basically not showing algebraically what was multiplied to both sides. So you don't want to put the answer yet. You want to just put down what was multiplied to both sides. So in this case, it was 5 times the negative 4. And then in the next step, you can see 5 of these together make up one whole. And now all together, we're just left with 20 negatives. So now in the next step, I simplify it. This times that is negative 20. And by getting our whole amount, we can see that this is our solution.